First day of our review, what we're going to be covering is sine, cosine, tangent functions. So the very first thing you should do is grab your calculator and make sure that it is in the correct mode. You'll want to hit the mode key and hit enter on degree at the beginning. Next, you would also want to write on your paper that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent's opposite over adjacent. What I'm doing here is going over a few problems that you should already know how to do, but we're going to represent all 6 of these things with fractions, starting with the sine of L. When I'm writing down sine of L, I'm going to be referencing this angle within the triangle. So I'm going to go ahead and label this side as opposite, this side as adjacent, and N as my hypotenuse. Now I reference that sine is opposite over hypotenuse. So the sine of L would be opposite, which is L, over the hypotenuse, which is N. L is 4, N is the root of 41. So 4 divided by the root of 41 is my answer. Now you're technically supposed to rationalize the denominator. We're not worrying about that right now. Going on to the cosine of L. Cosine is adjacent over hypotenuse, so adjacent to L is M, and hypotenuse is N, so M divided by N, 5 over the root of 41. And for the tangent of L, it's going to be opposite over adjacent, so opposite is L, adjacent is M, so 4 over 5. Is my answer for tangent of L. Now, for my other 3 answers, I'm going to change to where I'm looking at angle M on my diagram. So if I'm looking at angle M, now my opposite is M, my adjacent is L, and my hypotenuse is N. So now this will change things up a bit, and I'll just go ahead and write in the answers. The sine of M would be opposite over hypotenuse. That would be M divided by N, and that's going to be 5 over root 41. For my cosine of M, it's going to be equal to adjacent over hypotenuse. Now adjacent is L, so 4 over root 41. And then for the tangent of M, that's now going to be M divided by L, because opposite over adjacent, so M divided by L, and so that's going to be 5 over 4. And these are your 6 answers that you are wanting on that particular problem. Alright, here's example 2. I'm going to go ahead and write in what sine, cosine, and tangent are. And what I'm going to do really quick is referencing the 57 degrees, I'm going to write down what opposite, adjacent, and hypotenuse is. First of all, hypotenuse will always be the longest side across from the right angle. From the 57 degrees, this segment is the opposite leg, while this segment here is the adjacent leg. So now that I've written that out, I see that the adjacent leg is not being used on this problem. So it's not going to be cosine and it's not going to be tangent, because they both involve adjacent leg in some way or another. Opposite and hypotenuse means I'm going to be using the sine function on this problem. So the sine will be of your angle, 57 in this case, which equals opposite over hypotenuse, y divided by 15. Now I solve for my variable, which is y right here. On this case, I actually need to multiply by the 15 on both sides. So 15 times the tangent of 57, or sine of 57, excuse me, is equal to y. I'm done solving and I'm ready to use a calculator. Now I didn't say what to round to in the instructions, so I'm just going to say round to the nearest tenth here, and 12.6 is my correct answer. And that's the approximate value of y, so 12.6. If you didn't get 12.6 and you know that you typed it incorrectly, again, check the mode on your calculator and make sure you're not in radian, that you are in degree. Alright, on example 3, I am again writing out that sine's opposite over hypotenuse, cosine's adjacent over hypotenuse, and tangent's opposite over adjacent. And I'm yet again labeling the three sides on this triangle. So across from the 90-degree angle will be the hypotenuse. Across from the 28 degrees will be the opposite. And the x side, that's my adjacent leg to 28 degrees. Now that I've got that labeled, I see that there's nothing on the hypotenuse, so I'm not going to be using hypotenuse. That means I won't be using sine or cosine, since both of those have an h in them for hypotenuse. I'm going to be using tangent on this problem. So tangent of my angle, which is 28 degrees, is equal to opposite over adjacent, so 42 divided by x. Now I'm ready to solve for my variable. The way I taught y'all to handle this is go ahead and multiply by x on both sides, so that way you're not dividing by x. So it's going to be x times the tangent of 28 equals 42. Now your last step is going to be to divide by the tangent of 28. So divide by tangent of 28 on both sides. So x equals 42 divided by the tangent of 28, which you can type into your calculator now. Alright, once you type that in your calculator, it's going to say 78.99. Since I'm rounding to the nearest tenth, I'm just going to call that 79.0 for my value of x. And that's my answer. Alright, on this last problem we're going to be finding a missing angle, so it is a little bit different. And what you're going to do is go ahead and write out what sine, cosine, tangent are, like we do every time. And we label the sides of our triangle. I'm referencing from the x degrees right here, so this segment is opposite of it. 25 is my hypotenuse, being the longest side and across from 90 degrees. 16 meters is the adjacent leg to x, so there you go. Now let's see which side is not involved on our problem, which is the opposite leg. So I'm going to scratch out sine and tangent because they both need the opposite leg to be used. I'm going to be using cosine here. So the cosine will be of my angle, and it will equal adjacent divided by hypotenuse, so 16 over 25. Now in this case, I'll actually have to use that fancy maneuver to solve for x, where I'm going to use the cosine inverse to get x by itself. So my next step will look like x equals cosine inverse, that's to the negative 1 power of 16 over 25. To type this in your calculator, you'll need to hit second cosine on your calculator. So once you do that, you should get this answer of 50.2 degrees. And that wraps it up.